Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 287. Page 287, and today is our lesson number 180. The very first problem on page 287, problem number 131. In problem number 131, we are given a little chart there where we are told that we have 6 shipments that we have to send out. And the shipments are labeled as S1, S2, S3 all the way up to S6. And this is the fraction of the total cargo that needs to be shipped out. Shipment 1, the nature of shipment 1 is such that it's 1/4 of the total, it's 1/5 and 1/6 and so on and so forth. And these are the shipments. We are also told that however we send out the shipment, if you read the question properly, you will see that it says that the table shows the value of each shipment as a fraction of the total value of the 6th shipment. If the shipment on the first truck, had a value greater than half of the total value. So however you send out your shipment, the total value, the total shipment on the first truck has to be more than 50%. That's the condition we have to meet. Total value on truck 1 has to be more than 50%. We have to meet that condition. The question simply is, was shipment number 3 sent on truck 1, given the fact that however we combine a shipment, the total value on truck 1 has to be more than 50% and we cannot break the shipment. The way it is the way it is. In other words, we cannot take half of that and put it on one truck and half of shipment 1 on truck 2 and half of shipment 1 and truck 1. It doesn't work that way. It's sort of some sort of package. The simplest and the easiest way to tackle this problem is sort of dealing with these fractions, because you see these are very annoying fractions, and if you start adding and subtracting fractions, it'll be too much. The simplest and the easiest way would be for us to find a common denominator, and then once we have the common denominator, we don't have to look at the bottom part, we don't have to look at the denominator, we can just concentrate on the numerator, because they all have the common, that's why it's called common denominator, because the denominator is the same for all of them, so it plays no role. Let's find the common denominator. And when we're looking for a common denominator, our job to keep our numbers small and to keep our work as little as possible, as minimum as possible, our job is to find the common denominator that is as small as possible, which is known as the least common denominator, or the LCD. This is how we find the LCD. These are the numbers here: 4, 5, 6, 4, 4, 5, 6, 20, 15, and 10. This is how we find the least common denominator. Our job is to find the prime factors. Our job is to find any prime factor that is common to 2 or more of these numbers. To 2 or more. It doesn't have to be common to all of them. For example, we start out, we want to find the prime factors. The first prime factor that we can think of is 2. The first prime number that is we can think of is 2. Is 2 common to 2 or more of these numbers? The answer of course is yes. 2 is common to 4. 4 divided by 2 is 2. It has no common thing in 5, so 5 just comes down. 6 divided by 2 becomes 3. 20 divided by 2 becomes 10. 15 has nothing common with 2, so 15 comes down, and 10 will become 5. Can we go with 2 one more time? Let's see. This one we can do. This one has a factor of 2, and so does 10. So yes, we can go one more round. I actually didn't know that when I wrote down the 2. I thought I would have to erase it, but apparently there is. We could go one more round. But that does not mean that you can start out with 4. That's not how it works. You must start out with the least prime factor that you can find, that you can divide 2 numbers into. At least 2 of the however many numbers you have in the list. So 2 will become 1, 5 will remain 5, 3 will remain 5, 10 will become 5, 15 will remain 50, and this will remain. The next prime factor actually, the next prime number is 3. Do we find any at least 2 numbers that you can divide evenly by 3? The answer is yes. The answer is yes. 1 will come down by itself, 5 with nothing in common. 3 divided by 3 becomes 1. 5 comes down, 15 divided by 3 will become 5. There you go, we're almost there. Now we got a whole bunch of 5. We can divide all of those 5 by 5. And everything becomes 1. When everything becomes 1, that's the end of the story. Now the last step that I did there was not necessary actually. We didn't actually have to waste our time writing out all the ones here. I did it just to show it to you. But as soon as you get to situations where a factor goes into every one of them and every one is going to become 1, that's where you stop. So that's it. This is the least common factor. This is the least common denominator rather. Least common denominator, which comes out to be 2 times 2, which is 4. 4 times 3 is 12. 12 times 5 is 60. 60 is the least common denominator. Question is, how do we convert 1/4 into 60? How do we make the bottom 60? We have to make all the bottom 60 now. That's what it is. How do we make this 4 into a 60? By multiplying the 4 by 15. Well, if you can multiply 4 by 15, if you're going to multiply the bottom by 15, we have to multiply top by 15. So that's the shipment 1. So shipment 1 now is 15 on the top. Shipment 2 is 1/5. We have to make that into 60, multiply top and bottom by 12. That's our shipment 2. Shipment 3 is 1/6. How do we make it into 60? Multiply top and bottom by 10. That's our shipment 3. Shipment 4 is 3. 3/20. How do we convert 20 into a 60? Multiply top and bottom by 3. It becomes 60 at the bottom. Shipment number 5 is 2/15. How do we make 15 into a 60? Multiply top and bottom by 4. That's shipment number 4. Last shipment is 1/10, which is very simple. 1/10 multiply top and bottom by 6. Multiply top and bottom by 6. Voila, that's it. Those are our shipments. So what we're going to do now is to go back and rewrite these values for the shipment and pretend that the 60 doesn't exist at the bottom. Okay, I want from this point on, I want you to think of, forget the fractions anymore. We're no longer dealing with fractions. Think of this as total amount that we have to send out is 60 tons. 60 tons, and the nature of shipment 1 is such that it's a huge package which weighs 15 tons. The shipment number 2 weighs 12 tons. Shipment number 3 weighs 10 tons. Shipment number 4 weighs 3 times 3, 9 tons. Shipment number 5 weighs 8 tons. And shipment number 6 weighs 6 tons. And if you were to add them up, we will find 60 tons altogether. We are told that truck 1 must carry at least must carry more than 50%. In other words, more than 30 tons of the shipment must go on truck 1 for whatever reason. Okay? Let's do it then. We're ready to do the problem now. Now that we no longer have to do with the fractions, we can do the problem. The problem now becomes quite straightforward. In the first statement they tell us that S2 and S4 were shipped on first truck. Alright. S2, shipment number 2 and shipment number 4 were on truck 1. Now remember, our job is to be able to answer the question, was shipment number 3 sent on truck 1? We are doing all of this for that reason, for that and only that reason only, no other reasons. We just want to find out if shipment number 3 was sent on truck 1. If we can give an answer to that question definitively, either yes or no, that's what we're getting at. Okay, let's find out. Shipment number 2, as we can see, is 12 tons. Shipment number 2 is 12 tons. Shipment number 4 is 9 tons. Shipment number 4 is 9 tons. Shipment number 3, was it sent on truck 1? Let's find out. So we have 12 tons plus a 9 ton. Could we have sent shipment number 3? Shipment number 3 is 10. This is shipment number 3. This is 10. Let's erase this part here so it doesn't confuse us. This is shipment 2. This is shipment number 4. 12 plus 9 is more than 20. 21. 21 plus 10 is 31, which of course is more than 50%, because 50% would have been 30 tons. So that does do the job. But the question is that the only possibility? Could we have sent something else other than shipment 3 and still be able to send out more than 50%? We have to look here. We have 12 here, we have a 9 here. Well, instead of 10, if we had taken a bigger number, 15, we couldn't have sent out 8, you see? Because this is 31. So let's write it down here. This is 31 tons. This is only 1 ton more than what we need. With 30 ton is the 50%. This is only 1 ton more. So if you were to replace 10 by 8, it wouldn't make 50%. That will be 29. That will be less than 50%. But we could replace this 10 by 15. Instead of S3, maybe we have S1. S1 is 15. So now we have 15 plus 9 plus 12, and it is still, this thing is still more than 50%. So the question is, which one was it? Did we send out S1 on did we send out S1 shipment number 1 on truck 1, or did we send out shipment number 3 on truck 1? They can both do the job. The job being that we have to send out at least 50% on truck 1. And we can send out either of those shipments, shipment 1 or shipment 3. Which one was it? We really don't know. We have no way of knowing for sure. So the question was shipment 3 sent out on truck 1? To which the answer is maybe. Maybe it was shipment number 1 that was sent out on truck 1. Statement number 1 is not definitive. Statement number 1 does not provide us sufficient information to be able to give an answer, a definitive answer of a yes or a no. And therefore, A, D, B, C, E. Because statement number 1 is not sufficient, the answer cannot be A or D. It would have to be either B, C, or E. Let's look at second statement now. In the second statement, they tell us that S1, shipment 1 and shipment 6. Shipment 1 and shipment 6 were sent on truck 2, remember. So shipment 1 is 15 ton. Shipment 6 is 6 ton, right here. There's 21 so far. The question simply is, was shipment 3 sent on truck 1? Remember, that's the question we are answering. Let's ask ourselves, what would have happened if we had sent shipment 3 instead on truck 2? Because this is truck 2 we are dealing with here. If we had sent shipment 3 on truck 2, shipment 3 is 10. 10 plus 15 is 25. 25 plus 6 is 31. This is more than 50%. Because remember, the total shipment is only 60 ton. Is that possible? Could we have sent shipment number 10 on truck 2? The answer is no. S3, shipment number 3. So this implies, because the fact it turns out to be more than 50%, this implies that S3 could not have been sent on truck 2. Why? Because if we did, I'm not going to write everything, this is childish, I'm not going to write everything, it's too much, I'm going to explain to you. This implies that shipment number 3 could not have possibly been sent on truck 2, because as you can see clearly, if shipment number 3 was sent on truck 2, the total shipment would have been more than 50% on truck 2. We want total shipment, we are told that in the problem we are told that more than 50% of the total shipment was sent on truck 1. But given that fact, this is not possible. This is not possible. It would have to be for truck number 2, it would have to be, because of the fact that we are told it has S1 and S6, S1 and S6, which is 15 and 6. 15 and 6 is already 21. 15 and 6 is already 21. It cannot be 9 or more. This is 10. It cannot be 9 or more. It cannot be, well, it cannot be S4, because S4 is 9. It will either be 5 or 6. Well, this is 6. Well, then it would have to be 5. Oh, there you go then. One more time I'm going to explain it. Because of the fact that we are told that shipment 1 and 6 were sent on track 2, shipment 1 and 6, shipment 1 is 15, shipment 6 is 6, 15 plus 6 is 21, 16 plus 1 is 21, which means because the total cannot be 30 or more, because 30 would be 50%, this is only 21, which means whatever is sent, the third shipment would have to be something less than 9. Something less than 9, there are only two choices, 8 and 6. We already know that 6 is shipment 6 is already on it, so it's got to be 8. There you go. So the answer to the question was shipment number 3 sent on truck 1. The answer is yes, because it's not here. If it's not here, it's got to be on truck 1. So second statement by itself does the job. The answer is B. Alright. I hope I did not overdo it like I usually do. I explained too much, I think. But hopefully this was helpful. I'll see you tomorrow, okay? Bye now.